Hello. Today we're going over section 7.7, solving logarithmic equations. In this video, we'll go over problem number 1. When you're thinking about solving logarithmic equations, don't forget about the graph of a log. So remember the parent function, the basic graph of a log, has this anchor point at 1, 0, and then it kind of curves along the y-axis. So it has this vertical asymptote at x equals 0. So you can't plug in 0 or negative numbers. It must always be positive. So when you're thinking about, oh, what x values can I plug in? They've got to be positive. If you find something that makes that not true, extraneous solution. All right, let's look at a couple different ways to solve these basic logarithmic problems, and then you can choose which method you like the best. The first method would be to change forms. Right now, we have logarithmic form. Can we change it into exponential form? Yes, we can. Remember our Circle It Up song, all about the base, about the base. So this would be log base e of x equals 10. How do I change that form? Begin with the base and then circle it up to the other side. So e to the 10 equals x. And you're done. All right, let's look at B. Log base 5 of 1 equals x. There's a few things you could notice about this one. First of all, x is already isolated. Secondly, we're taking the log of 1. What's the log of 1? 0. There it is. That's our special anchor point, right? 1, 0. So you could punch this in your calculator if you use the change of base formula, or you could just remember the log of 1 or the natural log of 1 is 0. So, boom, x equals 0. There's no changing forms because x is already isolated. Let's look at C. We could choose this method to change forms, so all about the base. So 27 to the 2/3 equals x. Okay, can I keep going? Can I solve more? Yes. Remember when you're doing fractional exponents, think about taking the root first to get a smaller number. So what is the cube root of 27? Okay, that's 3. And then do 3 squared, which is 9. So here x is 9. Let's look at D. Same thing to change the form. So 3, all about the base, to the other side equals x. That's a number, but you could keep going if you wanted to. So x would be 1 over 3 to the 4th, and 3 to the 4th is 81. So in the end, x equals 1 over 81. Let's look at E. Notice x is already isolated. We've already got x alone, but is there a way we could clean this up a little bit? That brings us to method 2. So method 1 is changing forms, which in B and E we don't need. Method 2 is undoing. Can I make these two things the same base? So log base 5 of 5 to something equals x? And yes, you can. And then the log base 5 of 5 will undo each other. So 125 is 5 cubed. So this is 5 cubed, and since it's in the denominator, I can move it up and say 5 to the negative 3, and then log base 5 of 5 undoes each other. Boom, x equals negative 3. And then let's look here at the other one. What should I do with the natural log? So if I was thinking in the same method, so log base e of x equals negative 1, and then I'd say e to the negative 1 equals x. So e to the negative 1 is just 1 over e. X is 1 over e. You can leave it like that, or you can leave it like this, or you can punch it in your calculator. Remember, that's just 1 over 2.72, so it's just a number. Okay, that's kind of one way by changing forms. Another method is the undo method. So let's talk about that, and then you guys can choose. So method 2, I'll just say solve by undoing. Anytime you have a log, you can undo it by raising both sides to the same base. So I know that I have log base e of x equals 10. How do I undo? How do I get x out of that log? Well, use an exponent. So raise both sides to the base of e. E to the log e will undo each other, and x equals e to the 10th. Done. Okay, let's look at b. Remember, x is already isolated, so there's really no undoing. So if you look at b and e, these are kind of different problems because you already have x isolated. You don't need to change forms or undo. You can just know that the log of 1 is 0 or punch it in your calculator. And here you can see that you can get the same base. So 5 of 5 to the negative 3, and you can solve it that way. So that's kind of an interesting method. Now let's go back to C and F and think about the undo method. Okay, so how do I undo? This is base 27, so I would raise both sides to the 27. So this would undo each other, and x equals 27 to the 2/3. You get the same thing as if you change forms with all about the base, circle it up. But they're both really good ways to think about solving logarithms, so I want you to choose which one you want to use. Okay, let's look at D. So same thing, undo by raising both sides to the same base. So 3, log base 3 will undo each other, and you just get x equals 3 to the negative 4th, which is the same thing as if you thought about changing forms. And then same for f. Natural log is log base e of x equals negative 1, so raise both sides to that base. Logs and exponents undo each other. So this will undo each other, and x equals e to the negative first. So we get the same thing. I hope that helped thinking about how to solve basic logarithm equations.